Hey y'all, welcome back to Database School. Today I've got Dennis Magda on the show, and he is the author of a new Manning book called Just Use Postgres. And so we covered the breadth of Postgres. Yes, it's a relational database. That's fine. But we also cover using it for a message queue and JSON and generative AI and full text search. And he is, despite being the author of a book called Just Use Postgres, he is a reasonableist. He's not a maximalist. So we also cover a bunch of times when you shouldn't just use Postgres. But the premise of using Postgres until you don't need it anymore or until you graduate from it is very good and very reasonable to me. And so I think you will enjoy this episode. He's got a lot of energy. He's a delight. So please let me know what you think. And if you want to be on the show or you know somebody smart who should be on the show, let me know. And be sure to share it, subscribe, whatever you're supposed to do, please do it. Now let's get to the show. I am here today with Dennis Magda. He is the author of the book Just Use Postgres, which as we speak is being printed. It is a Manning book. It's available online right now, but the print copy or the print edition is in the works, which you can probably buy here in a week or two. And so, Dennis, thank you for joining us. Do you want to introduce yourself a little bit further?
Yeah, absolutely. And thanks for having me. I mean, I'm one of your loyal subscribers and followers.
Thank you.
I keep watching you. I keep learning from you because you kind of set the mark of how the content needs to be created for developers. And I'm a lucky one that I have finally a good opportunity, a good reason to discuss with you. So speaking about myself, I'm a software engineer, and I've spent, I've been crafting my skills for almost 20 years. I began working with Java. I was building Java applications, then I was building the JVM and JDK itself back in Oracle and Sun Microsystems. But then 10 years ago, I pivoted to the world of databases. And eventually, I just decided to master databases from inside. And the book which I decided to write is still for application developers, because even though I understand how the database functions, I understand I understand how the database needs to be managed, maintained, etc. I recognize myself. I sit at the top of the software architecture. I'm the one who helps you to design applications. But when you design and build those applications, I want you to understand not only, let's say, your favorite language or framework. I want you to know much better what goes down below. Let it be a database, let it be an operating system, or whatever else is your software stack. So you can just you can treat me as one of those software engineers who is focused pretty much on the entire architecture of your application, from the front end down to the operating systems.
That is awesome. And I love that because that's the way that I view myself. I don't go all the way down to, maybe as low as you do, but I view myself as somebody who really, really, really loves databases, but speaks and primarily identifies as an application developer. And I feel like that's a nice crossover to help bridge that gap. So when you were doing all this Java and you decided, hey, I kind of want to shift a little bit and learn more of the internals, the database stuff. What did that path look like? Because I feel like a lot of application developers these days are kind of moving up the stack. And so for the people that want to move down into the database layer, what did that journey look like for you and what were some resources?
Yeah, when I decided to move from the Java world to the databases world, I already was kind of deep in the internals of Java, because I spent, let's say, I spent 5 or 4 years working at Oracle, where I built the JVM and JDK itself. So basically, I was creating those APIs. I was enabling a Java virtual machine for different hardware devices. And most of the time, I was building Java, but I was coding most of the time in native C or assembly language. This is what I had to do. And that helped me, let's say, and why I decided to do that, the story, how everything began. I started as a Java developer. And as a Java developer, I had that passion to understand the language 2 levels down below. For instance, I was building the applications, but my next step was, okay, I want to understand much better how the JVM, Java Virtual Machine, functions. And after that, I decided to pass a Sun Microsystems like Java Professional certificate. I passed the certificate. I understood, let's say, okay, this is how JVM functions. It helped me to create and design much better Java applications. After that, I decided to go to the 3rd level, like way deeper, because I was disturbed, right? Like, I know how Java functions, but how Java integrates with the operating system. For instance, if I create a highly concurrent Java application using, let's say, several threads and using different mutexes, semaphores, etc., how is this supported by the Java virtual machine and the operating system level? And after that, I decided to join the Oracle. I decided to join Oracle and start building GVM itself. When I built it, let's say, GVM at Oracle, I went down below. I started, to learn how Java integrates with firmware, operating systems, and then how like everything is connected on the hardware level. And finally, I left Oracle because I had my own startup company. We were building it, for a couple of years. We had good clients, but eventually, as what happens to most of the startups, they fail. And after the failure, I decided, let's say, okay, I knew Java really well. And I said to myself, I know the Java concurrency really well, but theoretically. And then I wanted just to apply my theoretical knowledge in practice. I started looking for different companies who build highly concurrent Java applications. And I joined a company that was building a distributed database. And the distributed database was being built in Java. So that was a perfect match for me. So we all know that Cassandra, Apache Cassandra, is one of those databases. But I joined Apache Ignite. So Apache Ignite is a memory distributed database. Both Cassandra and Ignite, they belong to the same Apache Software Foundation. And that was a paradise for me because now I was learning how to build those distributed databases. And that was my shift. Like Java was the reason why I decided to pivot to the world of databases. And then eventually, let's say I spent 10 years, and right now, after joining Apache Ignite community and building Apache Ignite right now, 10 years later, I am here talking to you about Postgres. So there was some journey within the database world for me.
Incredible. Yeah, so you have a habit of going super deep. Like I said a second ago, I think you go, further down the stack than I do. That is confirmed. 100% confirmed. You went way further down the stack than I did. But then now you're the Postgres expert. And so you've written a book called Just Use Postgres, which I love. Great title, Just Use Postgres. And so how did we get from Apache Ignite to being able to write a Manning book? First of all, is this your first book that you've written? This is the first one. Yeah,
first one, and probably the last one, at least. But that's a tough exercise. I mean, that was a marathon for me. That's just a different conversation. We wrote it during pretty much short time. It took only around, let's say, 14 months. Just from the idea to the production. But it's all about, let's say, personal time management. This is how I wrote this book. Probably I will write another book once I retire, but not now. I have kids. I want to enjoy much more time with my family, with the kids. But going back to your question. So after Apache Ignite, I went to the company called Yugabyte. Some of the folks who follow the database landscape know. And why I joined Yugabyte? Because I just wanted to, because Yugabyte is built on Postgres. The company positions itself as a distributed Postgres, and this is in fact a distributed Postgres. And I joined them because they were believing a lot in Postgres. I used Postgres in the very beginning of my career. Before I went to Oracle to build Java Virtual Machine, I worked at a different company. We were building a high-performance social network. That was the time when Facebook was the thing. And there were many companies who wanted to create their own version of Facebook. So I worked for one of those companies. And our database that was year 2009. And our database was Postgres. So Postgres was my very first database. And we run Postgres in a sharded configuration. So we had several Postgres instances. That was before Citus data. That was before, let's say, Planet Scale, another, like Yugabyte. We implemented the sharding at the application layer, and this is where I learned Postgres. And then, let's say, how many, like 16 or 15 years later, I've already spent a bunch of the time with Apache Ignite, and then I'm going to Yugabyte, and this is Postgres. And this is where I started to learn Postgres. I worked for 2 or 3 years there, and then I found the gap. I found the niche that was missing because I positioned Postgres. I worked with application developers, and Postgres has a lot of wonderful content out there. Many books, especially many books, but most of those books were written for classical Postgres, and they were written for pretty much database administrators or for those who want to understand internals. But I wanted to create the book about modern Postgres. And that book, the primary audience for that book had to be application developers or software architects. So that was just a reason and story. And then I can tell you a story. What was the final reason, like why I finally decided to get in touch with Manning and start the project.
Yeah, please. I would love that. You're speaking my language. The whole, like, all the content is geared towards, content's very good. A lot of it is geared toward operators, DBAs, system people. Not very much of it is geared toward users, which in this context would be the application developer. And so I'm finding that same gap is still out there. And so I'm glad that you're here helping me fill that. So tell me, so you just reached out? You were like, hey, I want to do this. And you reached out and it happened?
No, so it was this way. So at Yugabyte, I came to Yugabyte with the knowledge of Postgres as a relational database, because this is how I used Postgres back in the days. But then at Yugabyte, I was on the developer relations team. So my goal was to communicate to developers and show them how to use both Postgres and Yugabyte to their best. And then at Yugabyte, I started to I learned a different Postgres. I learned Postgres that pretty supports JSON really well. Postgres that is capable of full text search, that can run full text search queries. Then we have this ChatGPT thing, and Postgres also had just a solution, the PGVector extension. And I was learning everything from different sources. Like I would find some video that talks about geospatial capabilities. Then I would find another wonderful article that shows how to use Postgres as a time series database. So I was collecting everything from different sources. And I started, scratching some ideas. Okay, so this is what probably I would need to create. It either should be a video content, but you took that niche, like you are the best who creates, and I knew that, like those days you worked for Planet Scale, and you produced that exceptional course for MySQL, and I knew that probably, let's say 1 year or 2 years later, Aaron would create a course for Postgres, so I need to do something else.
That's so funny.
And then what happened 2 years ago, like here in Tampa, in Florida, I met with a good friend of mine for lunch. We haven't seen each other for almost a half a year. And we kind of discussed many things like the family, like the past hurricane season. And also we spent most of the time discussing our jobs. We both in high tech. We build software. And he was telling me this story. He says, like, Dennis, I joined this company. And now I need to migrate my application from an on-prem infrastructure to a public cloud environment. But there is one big problem. The database which we run on-prem, it's a document database. I cannot move it to the cloud because it's not supported by our DBA team in that public cloud environment. So this is a big roadblock for me. And I ask, okay, so look, why do you use that document database? He says, like, come on, because my application, my platform is written in JavaScript. And JavaScript, naturally integrates with the document database because all the data is exchanged in JSON format, and then the JSON just gets to the database. It looks natural. And I'm asking, all right, tell me, like, what are the other options? Like, what are the other databases which are supported by your DBA team in the cloud? And he listed Postgres as one of them. And I go, okay, then just switch to Postgres. And he looks at me puzzled. He goes like, no, what do you mean? I mean, like Postgres natively supports JSON. It has special data types. It has special indexes. You will be able to query it efficiently. You will be able to traverse the JSON structure efficiently, etc., etc. And he looks at me, let's say, like with wide eyes open. He says, like, seriously? All right, let me give it a try. And that was the friend of mine. We used to work with him back in the days at that company building our own Facebook version. He knew Postgres as good as I did. And then I realized the gap. If my friend, who is like a principal software engineer who used Postgres in the past, doesn't know what Postgres is capable of these days, then there is a significant gap. And after that meeting, I started, drafting some book proposal. And then I kept meeting with different engineers and developers at other technical events and conferences. And many of them were surprised to know that Postgres can do full text search, time series, geospatial, etc. And what happened next? I got in touch with Manning, Jonathan Genick. He is one of their acquisition editors. He reached out to me saying, "Hey, Dennis, I saw you are going to speak at this Postgres conference. And my talk at that Postgres conference was about how to use Postgres, how to create a ChatGPT plugin for the chat for their marketplace using Postgres, blah, 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 blah." And we get connected. And I'm explaining him, Jonathan. So yeah, I don't want to write a book on that topic for two reasons. First, I'm not super interested. And second, if we write a book that explains how to create plugins for the ChatGPT marketplace, once we publish this book, the technology might already be stale. But Jonathan, so that I don't waste your time, I have you a counter offer. What if you write a book about Postgres? And this is like what the beginning of this story. And
that is awesome. Yeah, I think I've talked to Jonathan. I think I remember speaking with him at Manning, and he's a wonderful guy. And it's very funny to me that he reached out to you, and then you hit him with the Uno reverse card, and you're like, "I'm not going to do that, but I actually have a proposal ready to go." And so that brings us to the book, which is called Just Use Postgres. Like I said, great title. And so I'll just read out some of the chapters here. The first part is all about how to use it as you would expect. Use it as a traditional database. And then we get into JSON, full text search, extensions, generative AI, time series, geospatial, and a message queue. And so can you give me like a 1 or 2 sentence synopsis? I think I can put it together in my head. But what is your, like, when you're at a dinner party or you meet, a kid's friend's dad and he's like, "Oh, what's the book about?" What is your pitch? What is your thesis for this book, Just Use Postgres?
So it's the book introduces you, an application developer, to the breadth and depth of Postgres capabilities. So
ooh, that's good. That's tight. That's really good.
This is what it does, and it's written. What I did at Yugabyte, I was writing tutorials, and every chapter I designed as a tutorial. So you want to jump to PGVector, you want to jump to GenAI, you want to jump to message queue. Get ready just to read a tutorial, like 30 or 40 pages, like 20 or 40 pages tutorial. And you are not supposed just to read. You would need to start Postgres in Docker. You would need to connect, and then you would need to follow. And also, that was a hard exercise because the book is going to be quite thick, like 400 pages. But if you take a look at the title, if you take a look at the table of contents, I tried to cover so many popular extensions of Postgres and use cases that was quite challenging to decide what to put and what to remove. And eventually my goal was not to explain you all of the best practices, so tips or tricks or pitfalls, because otherwise the book would be just 2 times, let's say, larger. I just wanted the reader, a developer or software architect, just to feel that success. I wanted, let's say, you want to see how Postgres can be used as a time series database. Okay, probably spend a couple of evenings, follow this chapter, and then have this feeling, yes, I know that Postgres can do that because I did it right now. And then probably once you finish this chapter, it doesn't mean that you will start using Postgres for time series workload, but at least if that day comes, or if you need to give an advice to a piece of advice to someone, you will say confidently, yes, Postgres can do that because I followed that book, I did that. If you want to know details, more details, then probably you just need to go to the Timescale DB website, to the technical documentation. This is where they explain that in depth. All right, so I'm just going in all directions. Let me pause here.
No, this is great. This is your show. I mean, I'm just here to facilitate. So, I love the tight pitch, the breadth of Postgres. That's very good. So, let me say these again, and I have one that is a favorite that I not as a favorite that I am most curious about, but I want to hear first. Do you have one of these use cases that is a favorite? So we've got Postgres and JSON, Postgres full text search, extensions, generative AI, which is interesting, time series, geospatial, and message queue. So as you were writing, which one of these were you like, this use case is awesome?
So I would say that usually, probably, when someone writes a book, they already experts at at the topic they're just writing about. In my case, I had that vision. I want to create that book, and has to be the table of contents. But I knew only 25% of the content. So, which means that I knew really well, exceptionally well, how to use Postgres as a relational database. Then I knew how to use Postgres with JSON. When it comes to full text, and I also knew how to use it with the PGVector, because that's the time of GenAI. The other content I was researching. Basically, I was doing what you do. I watched one of your videos when you were showing how it was probably the SQLite course or Postgres course of yours, when you explained your preparation phase, how you would read books, how you would read Stack Overflow, Hacker News, you would do notes. My
Docs,
case,
all of it. It's brutal.
it's brutal. So my case was probably close to yours. Let's say I need to start writing chapter 5 about full text search. And then what it means, I would spend the week just learning, digesting, exercising. By the end of the week, I will have, let's say, a content plan. I will have a data model. I will have sample queries. I would have everything designed on GitHub. And then the next 3 weeks, I would be writing. I would be putting together everything. And while learning, I would say that I was just, from the favorite use case perspective, I wouldn't say that I have, the most favorite one, but I was convinced that Postgres truly became that general purpose database. So it's well known as a relational database, but right now, because of all of those non-classical relational database capabilities, such as JSON, full text search, and extensions, you can use it for much more. But there is also a caveat. If there is a general purpose database, if I say I truly love that Postgres became the general purpose database, but general purpose doesn't mean specialized. It doesn't mean that Postgres replaces Redis, or it replaces Kafka, or it replaces, any analytical database. There are different but for many workloads, for many scenarios, it might be just enough to use Postgres. So
let's dive in on that as it relates to full text search, because we know that there are specialized full text search engines and databases that you could use. And so talk to me about the capabilities of Postgres as a full text search engine and how far that can go before you have to pull the ripcord and say, all right, I got to bail out and go somewhere else. So let's just do full text search.
Yeah, from the full text search perspective, first, Postgres has a special data type called TS-vector, which stands for text search vector. And what it does, it just takes your text. It can be a description of movies. Those can be just text documents which you load it into the database. It analyzes the text. It splits the text into words, and then it converts those words into lexems. And lexems is basically, some representation of the word in a particular language. So it has that. It's easy just to split it. You just create the TS vector type, and then you say, all right, this is my text data, store it as a text search vector. That was the beginning.
If I may, as a lexeme, like when you have the words reading, reader, and read, all the lexemes would be just read, just kind of like
Yeah,
the base
yeah,
version of that.
yeah.
Okay. So Postgres has TS vector and it does that, converts it to lexemes, which makes the searching a lot more powerful because it doesn't have to be, pattern. It's just like it uses that underlying lexeme. Okay. So keep going.
Yeah, and it has, how does it do that? How does it do that? It has the concept of dictionaries. So a lexeme, this output and lexeme depends on the dictionary which is used for a particular TS vector column. And by default, the database probably supports like dozens, like 30 or 40 built-in dictionaries for different languages, like English, Germany, like French, Russian, etc. And you also can extend it. I don't know like how many people do that, but you can. It's Postgres. You can
Of course,
extend it. So after that, like generally, you have that column with TS vector type. Let's say that you're building some movie recommendation service, and you have the movie's description and titles. So you take the title, you can concatenate the title with description, and you ask Postgres, all right, now store this title and description as a TS vector column, and in the TS vector column, we'll have lexems for that combination of title and description. And after that, you can do the search. Postgres has special operators and functions for full text search. But also, as we know, like once your database starts growing, by default, if you don't have any indexes, then Postgres would be doing the full table scan. And then certainly once this TS vector type was introduced, there are specialized indexes which you can also use for TS vector columns. It's one of them is GIN index, general inverted index. So the same index which can be used for JSON data. And then the gist index also has a couple of flavors. So I don't want to go deep into the details, but generally Postgres has all you need. It has special data types for full text search. It has functions and operators, and it has specialized indexes so that your search is performant. Where does it come short, right? Because it doesn't make Postgres Elasticsearch, right? It doesn't make it Elasticsearch. First, we need to understand that Postgres, even though we have Yugabyte, we have CockroachDB, we have PlanetScale and other databases, Postgres is a single server database. So if you need just to have something fault tolerant, if you have too many documents, too much data, then you need to distribute this somehow. Elasticsearch can do that, right? Elasticsearch can split everything. To my knowledge, actually. Yeah, we do use Elasticsearch, but my understanding of Elasticsearch is not that deep. So you would need just to decide how to scale with Postgres, because in Postgres, the default index types might not be enough for your use case. There is another extension in the Postgres ecosystem called, I forgot. So generally an extension for the full text search, they support some special indexes and search types that are supported by Elasticsearch. But generally, let's put it this way to make it simpler. You can start with Postgres by using those basic capabilities. If at some point you hit their limitation, like scalability limitation, your index becomes too large, you cannot put everything into a single database, or you need to use some specialized indexes for full text search queries, then have a look at Elastic. Also, the point is that I don't want you, Postgres for full text search, I position it like this way. You already know Postgres, or your team already knows Postgres. You use Postgres as a relational database, or you already process JSON documents with Postgres, and now you have some use case for full text search. In this case, my advice would be to you, as long as you already have Postgres in your software stack, and you just need to introduce this full text search capability for your application, before you bring in Elastic, probably give a try to Postgres. But if you're on a different spectrum, let's say that you don't use Postgres, just like, yeah, I heard about Postgres, but I don't use it, and you just need to use some full text search capabilities, then just start with Elastic probably, because it's specialized. So my point is that I don't want you to overcomplicate your architecture or software stack. Just try to keep the number of components which you need to learn how to use, maintain, at a minimum. So if you already use Postgres, if you're already knowledgeable about Postgres and you just need to enable some full text search capabilities, give Postgres a try. If Postgres meets your requirement for full text search, go ahead and use it. If not, then you did the due diligence, and now you can switch to Elasticsearch or something else.
Yeah, that was actually, I mean, that was going to be my question is your rule of thumb, when you have Postgres in the stack, as you mentioned, give it a try. Just start with the JSON blob, start with the full text search, start with the time series. And if you have to move beyond that, you'll know. That's the question. Like you'll know the point at which you outgrow Postgres. But my guess is a lot of particularly startups may not hit that point for a long time, if ever. Are there specific, I guess you mentioned some of the Elastic operators, but it sounds like there is an extension for some of the Elasticsearch operators that you could install in Postgres. You mentioned scalability. So these TS vectors and these documents could get rather large. And so if you're ingesting a whole lot of data, that could be a sign that it might be time to move to something a little bit more specific. But if if you try it and it works, keep your operational overhead low instead of adding more complexity and more management. Is that kind of your entire thesis with like just use Postgres?
Yeah. And this is one of the items. What else? In the very end of the book, I have an appendix titled "When Not to Use Postgres," and there I list 3 reasons when not to use Postgres. The first one is basically when Postgres it's hard to use Postgres for your use case. For instance, you're already a fan of Postgres. You just want to keep using Postgres, but let's say that database is so much better. The database just hits it. Then just don't overcomplicate things. Just use another database if it's much better suited. Also, see this as an opportunity for yourself to learn that other database. Just broaden your understanding of the database landscape. So that's reason one. The second reason is that when you come, let's say, to a project, and that project already uses another database, and that database works perfectly fine, don't replace that database just because you want to use Postgres instead. Even let's say, even if that other database is a proprietary database and the company needs to pay a lump sum for it, let the company pay. All right, like don't break what already works. And the last thing, let's say you are doing the POC, and let's say you have 2 winners. You have Postgres, and then you have another database for your use case. And then you take a look, you need to make a decision. And then you realize that, okay, most of your team, the majority of your team knows the other database much better. And it will be much more complicated for you as a team, for your team, to get to Postgres because you don't know how to run it in production, you don't know how to upgrade, to maintain. So then probably just stick to that database because you just want to bring value for your company, etc. You just keep using that database, get benefit from the skills and knowledge of your team. So those are 3 reasons which I list when not to use Postgres. When to use, like let's say that you are new to Postgres, right? And right now we see this wave of Postgres popularity. Postgres is everywhere. Everyone talks about Postgres. I mean, you begin like it's great to start with Postgres right now. You want to use it for GenAI, give it a try because for most of the GenAI use cases, you're not going to build ChatGPT. You're not going to build Claude Code. By the way, ChatGPT, as far as I know, they use Postgres. But for most of the use cases, Postgres PGVector might be enough. Once you hit the limitations of PGVector, then probably you're building something else much more specialized than the majority of companies. Then switch to another database. Same for the full text search. Let's say you already kind of started doing something with Postgres using JSON. JSON is a good example for Postgres. Just it's fine to store JSON documents and just index them, query them. And then let's say if you need full text search, support full text search, broaden your experience. If at some point Postgres hits some limitation, if something is not provided by an extension, you have many other options to choose from.
You know, for an author of a book called Just Use Postgres, you're pretty reasonable. You're like, hey, I'm a reasonable, let's use it where it makes sense and not use it where it doesn't make sense. I like that. I fancy myself to be a reasonablist. Whether I am or not is up to the world to decide. But I like this line of thinking. The one that I looked at and I want you to tell me about is using Postgres as a message queue. So give us a high level. What is a message queue? Why would anyone use it? Most people probably know, but in case they don't, give us a high level, and then give us how you can do that in Postgres, and then what are the specialized, because for everything here, there's a Postgres version, and then out in the world, there's a dozen specialized versions. So let's start high level, then go Postgres, and then we can talk about graduating from Postgres.
Yeah, a true reason, I didn't want to write a chapter about message queues. Because
I'm sorry I picked that one.
Oh no, I was very skeptical. What happened? What changed my mind?
Okay.
When I had that proposal, and before you start writing the book, the proposal needs to be reviewed by dozens of people. So the publisher, they will recruit different folks like volunteers, experts, and they would read your proposal and give you some suggestions. And there was one of the reviewers who checked my table of content and said, Dennis, the table of content is great, but you're missing one important, use case, like message queues. And I was like, no, not message queues. That's probably just too much for that. Let's keep it. And then 5 months later, we released the first 4 chapters of the book under the Manning Early Access Program, which is like MIP, Manning Early Access Program. And I just went to Reddit. We have this subreddit for Postgres, and I posted, okay, folks, this is the book. It works. Let me know what you think about the table of contents and blah,
You're
blah, blah.
You're a brave and eventually, man, first of all, going to Reddit to post that. So I'm curious to hear what they said.
Yeah, because I guess that was a very risky project for me, because I had that idea in mind, how that book should look like. But I wanted just to get, and the publisher also wants it, just to get some external feedback. And eventually, there were several folks on Reddit who published, Dennis, it's all fine, but where is the message queue? And under those posts, I had, let's say, like dozens and dozens of thumbs up. And then I'm returning to Jonathan, and I'm telling Jonathan, we gotta do something. I know that you wanted me just to stick to 350 pages, but we gotta add this chapter about message queues. We have to. Because if we don't do this, then the Postgres community will just hit me badly. So it's better just to also include something about that use case. And eventually, that was the very last chapter. But I enjoyed learning how to use Postgres as a message queue. Now I understand that, yes, it can be used. There are many valid use cases, but also it does not replace Kafka. No, there are different.
So tell us, how do you use it in Postgres? Yeah.
So generally speaking, you can use any relational database or document database as a message queue, because what you do with message queue, you have a producer, you have a consumer. Someone puts messages into a table, and then someone reads those messages. And then in Postgres, you put everything in a table, and you put everything in just you create your schema, and you put everything in there. And usually in message queues first, what you do, you would create a table. You would probably have a message ID, which is auto-incremented. It can be just big int, or it can be UUID7. It's up to you, whatever you want to use. And then the actual message payload, it can be JSON or JSONB. So this is where you start using JSON as well. Yeah. And so you put data, you read data. So what happens after that? Then you need to use, whenever you put or read data from, when you read, if there are several consumers who read data from this table, consume your messages, you need to use the skip logs capabilities of Postgres. So basically, when one transaction, when one select request to Postgres tries to get the next message to read, it skips all of the messages which are already logged by other consumers. So you have this, from the performance standpoint, you have, let's say, some built-in features such as skip log. Next capability, of Postgres. Let's say that when you're building some simple, let's say, message queue, or you use it Postgres for your job scheduling needs. You have some task, you put the task into the database, and then someone takes this task, executes it. But what if you, let's say, if you have some high load workload, when you generate so many messages daily, then one table is not enough. In this case, you can use Postgres partitioning capabilities. So let's say you have this message queue table in this Postgres, and you say, all right, now partition this table. And you partition, let's say, by date. So you will have those children tables. And let's say the first table will store the data for the previous week. The current table will store for the current week, etc., etc. Postgres partitioning can be used here to scale everything on one database server. Then you will be struggling with what? You will be struggling if you start partitioning your table for messages. Then you would need to maintain those partitions. And generally speaking, you will be able to build. Postgres already has many built-in capabilities that will let you to create that message queue. And eventually there is a specialized extension, and not one, but so in that chapter first, I show you how to build a custom message queue using Postgres built-in capabilities. I do this so that you understand the mechanics, so that you understand not only how it functions internally, but also so that you understand limitations of Postgres as a message queue. And after that, I finished the chapter by showing you how to use PGMQ, Postgres message queue. This is just an extension. You just install extension, you easily create your queue, and then the queue internally will be using all those skip logs. It will be using partitioning. It will be using everything which we discussed, before in the chapter. And also in the chapter, I explained when Postgres is not good. So when Postgres does not replace Kafka.
Okay, so let's stop there, because we've scaled up before we break out of this scale. We've scaled up from using just single plain old Postgres on a single table with an ID and a blob and some built-in SQL stuff, skip blocks, right? So that's where we can start. And then you said still within Postgres, so we haven't broken out yet. You've got your one table and skip block. Then you've got your table that you can partition, and now you're increasing a little bit in complexity, where you're having to manage partitions with Partman or whatever else you manage partitions with. And then we have gone to the stage 3, which is PGMQ, that automates and systematizes a lot of that stuff that we did in stages 1 and 2. And so you've got PGMQ. And now we're breaking out. So this is a long way, right? You've scaled up pretty far with just Postgres. And then once you blow through PGMQ, when is that point when you are like, oh, PGMQ is no longer working? Do you have any heuristics or rules of thumb or things to look out for?
So first one is when you're dealing with the write-intensive workload. Because Postgres, you can deploy Postgres in the configuration with one primary, right, and then as many replicas as you like. So, but generally, that will allow you to scale to many consumers of your messages. But when it comes to the producers, if you have many producers, then you can hit that contention, because all of them have to write to your single Postgres server. You can start scaling it.
I like that.
Yeah, so you would need to scale it, right? You would need to scale it somehow. Kafka does this by definition. Kafka is distributed. So you create as many Kafka nodes as needed, and then you subscribe to those topics, etc. Also, Postgres in Kafka you have the concept of topics. I've never used actually Kafka in production, but I created many demos. I use it for my pet projects. In Kafka, you have the concept of topics. So let's say you have many topics, and different subscribers and consumers listen on those topics. There are notifications in place. You will be notified by Kafka. You subscribe to that. You notified, and then you just read and Kafka is there like a log. It's like a log-based system, right? You're writing everything to Kafka, and let's say that consumer was not available at the time when that event was written. So you then can connect later, and you can read that event from Kafka. In Postgres, now you would need to manage the state of your message queue. So you would need to decide when that message is read. So, or do you want that message So what happens if one consumer reads this message? Do I need to delete that message, or do I need to archive that message, or do I need to wait while, let's say, another consumer, let's say, comes and reads that message? In Kafka, it's much easier to manage. From the notification standpoint, Postgres has the concept of listen notify. It's a built-in feature, but there is a trick. So you can, for a simple use case, first, you have your client applications that want to be notified when a new message arrived in Postgres. So you can listen to those notifications with that listen notify capability. But you have to be connected to the primary instance of Postgres. Why? Because when a new message goes, when a producer writes a message, it goes to the primary node. And the primary will execute this notify on the primary. So you will not be notified on the replicas. You always have to maintain a connection to the primary.
So there's your bottleneck.
Yeah, and there is something else. I listed some of those, and from the high availability standpoint, I listed some of their items in the book. But for everyone, it doesn't mean that it's still Postgres can be used, especially as a job scheduler or as a message queue. But I want people just to take everything with some grain of salt, especially if you're a software engineer, because there are so many articles, there are so many successful implementations and usages of Postgres as a message queue. You can read all of them on the internet. And I read that. I believe that Postgres can be used as a message queue. But also, I'm a very reasonable person. And a couple of, not days ago, but probably previous week, Gunnar Morlin, he is one of the known tech guys in the Java community, and now he joined Confluent. And he wrote an article just to make some reasonable discussions on Postgres versus Kafka. And he outlined some of the limitations and warnings which I listed in the book. And right now, whenever I see someone comes and tells me, just dump Kafka, use only Postgres. Postgres can be used as a message queue. It's just so much better than Kafka. I would usually just refer to that article of Gunnar saying read that first.
I saw this.
Yeah.
Was it something considered harmful?
Yeah.
Is that the name of it?
Yeah, I will send it, but you can Google for Gunnar Morning and then just use Postgres.
That's exactly what it was. The title is "You don't need Kafka, just use Postgres. Considered harmful," and that it's in quotes. And I totally saw this. So that's funny you bring that up. I saw this and read this. That's great.
Yeah. Long story short, I enjoyed learning how Postgres can be used as a message queue. You can and should use Postgres as a message queue. We have an extension, but as with any other capabilities which I cover in the book, be reasonable. Just don't be fanatic of the database. If it's hard, if it's arduous to support Postgres for that use case, just switch to a specialized database, because the Kafka community, they're focused on building that streaming platform.
Sure. Yeah.
When it comes to PGMQ extension, it was created by a much smaller number of contributors. That's why, but you have options. And if, let's say, Postgres works for you as a message queue for your workload, excellent. You don't need to bring another solution to your software stack, because still, if you bring in Kafka, guess what? You have to maintain it, you have to upgrade it, you have to dive into the details of Kafka if you want to build something, scalable. You don't want to have surprises in production. You need to know Kafka well enough. That's actually my approach how to handle all of those conversations.
You're fighting an uphill battle telling a bunch of software engineers to not be fanatical. I support you, but you know what? We love to be fanatical, and everybody that doesn't agree with us is an idiot. So I appreciate your good fight out there. Talk to me this last one. So I want to talk about all of these, but we don't have time. So I guess I'll go read this book. So well done there. Talk to me about Postgres for generative AI. So I'm familiar with PGVector, but what is the whole? Give us a sense of the breadth of Postgres and its capabilities for Gen AI.
So we discussed with you the full text search in the beginning.
Right.
So when Postgres, the full text search is built-in capabilities of Postgres. It's just in the core database engine.
And that was TS-Vector.
Yeah, and that was TS-Vector, and then you have those specialized indexes in index types such as gin index, and you have special operators. When it comes to embeddings, vector embeddings, there is no any specialized type in the core database engine. But before this GenAI boom and era, we had the PGVector extension. It existed before. And the extension supported the vector type. So the vector basically can store an array list of floating point numbers. And then let's say we have ChatGPT, we started building the first GenAI applications. We have the embedding models. And what those embedding models let's step back. So generally what you expect, because in that chapter I talk about Postgres as a vector database. So what a vector database does, vector database takes you have your embedding model. That embedding model takes your text data, image data, audio data, and produces what? Vectors. And those vectors are just multi-dimensional arrays of floating point numbers. And then you just store those floating point numbers unreadable for human, not human readable, in your database, in your vector database. And then the vector database also has to support special operators like to calculate the distance. Because when operators and indexes, because once you have those vectors in your database, what you do next? You run the vector similarity search. Let's say that you created embeddings for your movie recommendation service. You have titles and descriptions. You take this title and description, you pass it to an embedding model. Embedding model generates everything for you and puts it into a vector database. And then your user comes to your website and searches, all right, I want to watch this movie that blah, 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 blah. Then your application takes this search string, feeds that search string into the same embedding model. The embedding model produces some vector, and then you take this vector and perform the vector similarity search across all of those movie embeddings which you already have in the database. And then you're getting, let's say, the list of the movies which are close in that vector space to the search string the user provided. And so generally Postgres, the PGVector extension, what it does, it has this vector type that is capable of storing embeddings. It supports their similarity search operators, and it also supports two index types, I flat, I always forget how to pronounce it, and
same.
HNSW, hybrid small world graphite.
Something, yeah.
yeah. So it has it. And it will work, but there are also limitations because that extension is, I think, there is only one main maintainer for that extension.
Whoa, and really?
Probably, I need to double check, but in the beginning there was just one main maintainer. I don't know, like if the things have changed since that time, but in the beginning,
that's got to be up there with time series and PostGIS as like most important ones.
Yeah, we need to double check. Probably something have changed when it comes to time series and PostGIS. There are dozens of people, right? If not hundreds, who work on those extensions. With PGVector, I don't know. But generally, PGVector, it allows you to use Postgres for GenAI applications. But then, so many right now complain about their indexing capabilities. Because when I was writing the book, this space is developing so fast. HNSW, that was the #1 index. But that index, like how it looks like, Postgres would need to create a multi-layer graph structure. And it would need to put that graph into memory. So this HNSW is memory-bound index. And plus, it takes a lot of the time just to build it. It's just compute intensive. Index construction time is long. And I see that many people, I've never tried this in my own project. Like I never hit that limitation, but many say that once you start hitting, let's say, dozens and millions of vectors, then you would need to allocate, much more RAM for your HNSW index of PGVector. Or if you need to rebuild the index from scratch, it will take much more time. Same as in Postgres world. So, but I believe that it's so if you hit this limitation with PGVector, then all right, check other specialized vector databases. We have Pinecone, we have Turbo Buffer, and a list goes on and on. At the same time, the creators of Timescale DB, they created their own extension called PGVector Scale. It's built on top of PGVector, and there they introduced a new index type, which is more memory friendly. So you also can create a very efficient index structure with high recall, but that one is going to be utilizing disk space a lot. So you will be able to cut costs on your memory usage. So what I believe that probably right now, the Postgres might be lagging in the GenAI capabilities because the specialized vector databases are developing so fast. But also, I saw what's happening with the Postgres community. There are so many fans in this community. There are so many vendors in this community. Then Postgres, I think, will catch up anyway. So anyway, the long story short, PGVector exists. PGVector supports special vector type for your embeddings. It supports special operators and functions and supports index types. So give it a try, especially if you already use Postgres. It's open source, it's free, right? You can run it everywhere because most of those vector databases which we have right now, they're proprietary. Everyone wants, just to, everyone got that VC funding. They want just to become profitable. In Postgres, just take it and use it. And if you hit the limitations of PGVector right now, then okay, switch to that proprietary database, start paying to them. But remember that Postgres can be improved in that direction in the future.
Man, I gotta say, I love your energy. This is great. I'm just sitting here and listening, and this is so much fun. Okay, so we do have to wrap it. I want to hear, you mentioned early at the beginning, you're never writing a book again. Just walk me through 14 months. You said you have kids. I assume you have a full-time job. You're talking about reading everything on the internet that exists to get your full, well-rounded scope. How did you pull that off in 14 months? What was that process like? And then we'll send people to go buy it because my goodness, you've deserved it, you've earned it. But what was that process like?
You have to. I used to run a marathon once in San Francisco. I would never ever do this again. It was torture. Even though I was preparing for a long time, still I was just the last 4-3 miles. I thought I would die. And but that kind of helped me to build this, to develop that resilience. You don't have any compromises to yourself. You need to put together a plan. And then I'm planning to create a blog post where I will show how everything looked like. So I had a schedule, which I followed strictly. I would write or study from Monday through Thursday between 8 p.m. and 10 p.m., 2 hours every day. I have to do that. I have to go to bed, let's say, at 10:15 because I have to wake up at 5 or 6 in the morning. I have kids, right? What happens after Thursday, Friday, and Saturday? No any writing, no any Postgres, just I'm disconnecting from the book. I want to spend all those days with my family. We have, let's say, this tradition, every Friday we bake pizza at home. This is our pizza day. No post, no
dream.
Any books. Yeah, no,
we're the same person, Dennis. That's all I ever want is to do Postgres and pizza. Okay, sorry, keep going. This is great.
Yeah. So for Friday and Saturdays we're off, and then on Sunday I would get book. I would wake up at 7 a.m. I would just do some exercise, and then I would be writing. I would be studying for 4 or 5 hours in a row. So that was my plan. And I stick to this plan during those, let's say, 14 months. It was the hardest, but what I also learned, and when you listen to many, let's say, podcasts, people keep talking you never want to do anything else on Monday evening because you're already disappointed, right? This is Monday. It's the beginning of the work week. I don't want to go back to my work, right? And now you want me just to start writing something, but no, you just fight this temptation. I never wanted to write on Monday, but as soon as I would start writing, Like 5 minutes later, no, I'm fully focused. I'm just doing that. And then it's easier on Tuesday. It's much easier on Wednesday. On Thursday, I'm just enjoying this process. Then I'm taking a break on Friday and Saturday. Wonderful. I already look back at the last 4 days, how much I could accomplish during those like 2 hours every day. And then on Sunday, I'm just enjoying, let's say, 5 hours of my time nonstop studying and writing. So that process worked for me really well. But that's tough. And that was easier in the beginning, but it was much more difficult for me to finish the last 3 chapters. It's like, the last miles of the marathon. It's like, no, if not the manning team, I would never ever start, and I would never ever finish this book without manning, because now that was not my responsibility. I owed those people. Those people trusted me. I could not let my team down, because the manning was my team, and they're still my team, because we still have to promote and sell this book somehow. Yeah, so that's why right now I'm kind of recovering. Now right now I finished talking to you. I will get back home and I will spend much more time with my kids. I will be reading the book for them today. Today is what? Thursday. I don't need to write. I will be reading some book for my kids. And I couldn't do that during the previous 14 months. Now I'm enjoying this process.
Well, I don't know what your energy is normally like, but you seem great. It seems like you're happy, you're flourishing, and so I am happy to see that for you. That is a very good and very inspiring, frankly, process, because I, of course, have aspirations, dreams, hopes, goals, and everyone has 2 hours a day. I have, as you might know, I have 4 young kids, and I still have the hours of 8 to 10 p.m. Those hours are still available to me. And so that is an encouragement to me, and hopefully to everyone else as well. So thank you for sharing that. Tell us, give us your full pitch here at the end. Who should go buy this book, and then tell us where we can follow you online.
So who should buy it? So generally speaking, I keep talking about application developers, because I was writing this book for an application developer in mind, because I didn't want to write this book for a database administrator or a database engineer who builds those. They already have so much content for them. But eventually what I created, when the book has a review process. Let's say once you write for every 1/3 of a book, you would go through a review process. It's like, let's say on GitHub, you create a pull request for your feature, and your feature would be reviewed by a bunch of people before it gets merged. The same with the book. I would create the first 4 chapters of the book, and then it will be reviewed by dozens of people. They would provide feedback, and then you would spend weeks trying to address this feedback. And eventually but that exercise it delayed the release of the book by 2 months, because I did not expect that that we would have 3 large review cycles for the book. But they were priceless, because they helped me the reviewers, they helped me to improve some mistakes or focus on some details. And also they helped me to see that the audience is much broader than application developers. So generally right now, whom I would advise it, I would say that, like, if you're an application developer or software architect or some technical expert, then you would definitely benefit from this book. You will be able to learn it. But then it depends, like, how you're familiar with Postgres. If you're a newcomer to Postgres, then my advice to you would be just to start reading the book from the very beginning, like from chapter 1. At least read the very first 2 or 3 chapters. After that, so that you understand, the foundational capability, the foundational relational capabilities of Postgres. After that, it's up to you. It's Wild West. Pick, the chapter you're most interested in. Let it be time series or message queue, etc. But also the book, what I realized, it's not only for newcomers, because I wanted to create it for the newcomers. That was my contribution to the Postgres community. I wanted to create the book for application developers, which Postgres missed. But then I realized that many of those who already use Postgres for a long time, they also don't know some of the extended capabilities, such as time series, etc. If you belong to that category, you're already Postgres expert, but you want to see how to use it for GenAI or how to use it for geospatial workloads, just jump to the chapter and just keep trying, keep learning. From the when it comes, yeah. So this is
so for those people, it's more of a like a reference or a handbook where they can hop to the section they don't super know about and get up to speed. And for the intro person, they can start at the very beginning, which is Postgres as a relational database, and they can get a nice firm foundation there.
Yeah. Exactly. You just want to see it in action. You want to see, you don't want, for instance, if you want to learn how to use it for time series database, it's not going to be a comprehensive guide. No. I spent only like 35 pages on time series. It's impossible, but you will see it in action. It's like a 35 pages tutorial. You do this, you see it works, and then if this is your thing, then just go to the timescale DB documentation, and this is where you will find most of the details and nuances.
I love that. Where can people find you and follow along with you online?
So you can find me on Twitter. You can find me on LinkedIn. I was dormant there during the last 14 months because now probably, let's say after taking a break, I will get back to those platforms and we'll start, posting something. But pretty much if you want to connect with me, I check Twitter and LinkedIn regularly. If you want just to connect, send the message. This is where you will find me.
Perfect. I'll leave links to that, and obviously to the book and everything down below in the show notes. So for the dear listener, check out all of those links in your podcast catcher of choice or on YouTube if you're watching there. And if you want audio or video, we offer both. And I think, Dennis, correct me if I'm wrong, I think the way you ended up here today is you sent me an email and you said, I want to come on the show. Is that right? Am I remembering correctly?
Yeah, exactly. But what I said in the beginning, because I followed you, Aaron, for a long time. I learned that you existed when I used to work at Yugabyte, and you were producing exceptional content. I started learning from you. I bought your course that teaches how to set up everything for the recording. Exceptional one. No, like I paid you for that course, full price. And then I didn't know that. Yeah, and actually I ended up in your database, in your customers database, and eventually I'm receiving this email from you saying, "Hey guys, I'm going to start this database university project." And I'm telling, wonderful. And that was, the day when I was already, we've been preparing with the publisher the book for the production, like the last, milestones. And I'm telling, I want to talk to Aaron. I mean, like, probably he no longer wants to talk about Postgres, but if he still wants to have an episode about Postgres, we have this good topic, like the book that is about to be published. So I decided to respond to you, and then wonderful, you responded to me. And
I did not. I thought it was like you sent me an inbound email. I didn't know the whole backstory. That is incredible. I can't believe you bought screencasting. That's so fun. So the point is, dear listeners, help me source people for the show. And in fact, if you are interested in doing things in the database world like Dennis is, you can just send me an email. If you are a PR company, please don't send me an email. If you're an interesting person, please do send me an email. I would love to talk to more people on the show. This is super fun for me. And if y'all could leave comments and thumbs up and subscribes and whatever you think you can do to help the show, that would be awesome. And Dennis, thank you so much for joining me. This has been a delight.